For decades, data lived inside a very strict architecture. If you wanted to store information, you locked it into relational databases, rigid, tabular formats where every record had to fit perfectly into predefined rows and columns. Because every database shared this identical, strict uniformity, software engineers could use a single, standardized language, SQL, to query and manage almost any system in the world. It was a highly predictable environment. Developers traded the ability to create flexible, unique data structures in exchange for universal, easy-to-use interfaces. Then, the data demands of the modern web broke those strict tables. To achieve massive horizontal scale, engineers adopted NoSQL databases, scattering data into flexible documents, wide-column architectures, and key-value stores. But breaking out of those rigid columns created an immediate problem: visibility. The standardized tools developers relied on simply couldn't parse these highly distributed, schemaless architectures. Relational UIs failed when they encountered nested objects and decentralized nodes. To restore visibility, developers built specialized interfaces designed to interpret these specific architectures. Abandoning the schema forced a total redesign of the developer's toolkit, shifting from universal terminals to bespoke visual engines. Document-oriented databases like MongoDB group related data inside a single, flexible BSON document, operating like a nested tree structure. But inside a single collection, every record can maintain a completely unique, unpredictable schema. To navigate this mismatch, developers use MongoDB Compass, a graphical interface built to instantly map and interpret these dynamic, uneven documents without relying on a command line terminal. Compass features an aggregation pipeline builder. Think of it as a visual conveyor belt, passing abstract data blocks through sequential filtering, mapping, and sorting gates. Engineers can preview multi-stage transformations step by step, generating a clean, uniform dataset without writing nested code. By translating schemaless data into a visible, drag-and-drop workflow, Compass solves the document problem. When dealing with massive global server clusters, developers turn to wide column stores. Databases like Apache Cassandra operate on a masterless, peer-to-peer architecture. Every node shares an identical role, continuously exchanging state. Without a master node directing the show, routing queries across this decentralized ring is highly complex. The solution is the Cassandra Query Language Shell, or CQSH, a command line terminal specifically engineered to bridge the gap in a masterless network. This shell uses a syntax that deliberately mimics standard SQL, so developers can easily adopt it, but it operates natively on top of the wide column framework to execute high-velocity reads and writes. Crucially, CQLSH gives developers access to tunable consistency. Right from the terminal, you can manually adjust data accuracy per query, requesting an instant response from just one node, or demanding strict consensus from the majority of the cluster. It grants database engineers precise, centralized command over a system built explicitly to have no center. Then there is the demand for extreme speed. Key value stores like Redis are the fastest NoSQL databases available, functioning as massive, distributed in-memory hash tables. The database engine treats the value payload as an opaque blob, a sealed box it doesn't inspect. And because this data lives entirely in system RAM, the available space is strictly finite. To prevent overflows, developers rely on Redis Insight, a diagnostic workbench built to peek inside that finite memory. It visually unpacks those opaque blobs, translating raw memory into readable structures like hashes, lists, and sets. It includes powerful built-in profilers that visually trace slow-running operations and map exact memory consumption across the nodes in real time. By making the hidden data visually accountable, Redis Insight ensures that lightning-fast in-memory caches don't devolve into unmanageable black holes. Compass, SQL Shell, and Redis Insight function as active interpreters. They sit between raw data and the developer, providing the optimization and visibility needed to manage scale. They take the raw, chaotic mechanics of NoSQL, the flexibility, the global scale, the extreme speed, and translate them into formats that human engineers can actually read and control. Database management has fragmented. No single terminal can visualize every data structure simultaneously. These interfaces are essential to the utility of the system. Without tools to command the flexibility and speed of the backend, the data remains unreachable.